Yes, sir, you are audible, sir. So good afternoon,
Yes,
everyone.
sir.
I invite you and I welcome you all in the second session of this GIAN course. The speaker for our this second session is Professor Rohit Mehra, sir. At present, Professor Rohit Mehra, sir, is working as Dean of Research and Consultancy and Department and Professor in Department of Physics at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. And he is currently heading the Radiation Monitoring and Assessment Lab in Department of Physics at NIT Jalandhar. He has been an active researcher in field of environmental radioactivity for past 20 years. He has supervised 19 PhD students and currently supervising 6 PhD students. He has published more than 200 research papers in journals of international repute, and he has been selected as among the top 2% scientists of the world by Stanford University. Rohit Mehra pioneering research and dedication to advancing knowledge in environmental radioactivity is a source of inspiration for all of us. I invite Professor Rohit Mehra to deliver the talk on measurement of natural radioactivity and its impact on human health.
So, thank you, Abhishek, and thanks for the nice introduction. I think we have already concluded this introduction portion in the inaugural session. So, from the tomorrow onwards, there will not be any further introductions of the speaker because we are the only two speakers, Dr. Tokonami, which you have already interacted. Am I audible now? Am I audible?
Yes, sir.
Yes, sir.
So, Dr. Tokonami has given you an idea about the radon and its isotopes and its measurement techniques. So, today I will be giving you a very basic idea that what is natural radioactivity, because we will be planning this course during the tenure of 5 days in such a fashion that after the 5th day you are basically having an expertise in what are the different techniques which are available for the measurement of natural radioactivity and how this radioactivity could impact the human beings, why it is important to study the natural radioactivity in the environment. So with the advent of radioactivity, you could say if you just start, this slide gives you a basic idea that as he is the Benjamin Franklin is a person who basically invented this technique in such a fashion that lightning was electricity by the kite, and during a keystorm he invented the glass also. And based upon this, Benjamin Franklin was the only person whose picture was published on the dollar, United States dollar currency. So he says basically life is a tragedy that we get old too soon and wise too late. So the basic idea behind this is like we learn so many things in our environment, but we understand those things at a very later stage. So that is why once we start this career as a environmentalist or a nuclear physicist or a person who is dealing with the environmental radioactivity, you should have a basic idea that what we are going to measure, why we are going to measure, and how we are going to measure. Because as a expert or as a scientist or as a researcher, you cannot measure whole of the natural radioactive elements with a single technique. So you require different techniques for measurement of different types of radioactive materials, sometimes in air, sometimes in water, sometimes in soil. Like in the morning, Dr. Tokonami has discussed so many things about the radon. So why radon is important, he has already discussed, because once we say we are going to measure a gas or a material which is in a gaseous state, that is always uncontrollable. Because once it is an inert gas, which is a decay product of radium 226, once from the 226 radium, this alpha particle is emitted out, radon is generated, and radon is in a gaseous state. So once it is a gaseous state, it is uncontrollable. So these were the few facts which were about the Benjamin Franklin. So which I just want to introduce you, because he never presented or patented or any innovation, but still he was very kind enough to deal with the phenomena where we could say that he was capable to understand the problem. So not only the scientists who are important, it is the basic understanding is very important. So that is why I was very much interested in presenting you these 2 or 3 slides of Benjamin Franklin, to make you people aware that though you are working or you are not working in a particular area of a natural radioactivity, but as a science student, as a science graduate, as a human being, you should have an idea to understand that how you are being exposed or why you are being exposed, and once you have been exposed, what type of effect your body could have. To start with, radioactivity, it was discovered very early in 1896 by the famous scientist E.H. Becquerel, so who was working on some of the uranium salts. So once he was working on with the uranium salts, were having a photographic plate, he said that they were uranium salts were affecting some of the photographic plate. This is a very important phenomena which you might have studied in your graduate classes. Now, the basic idea of this presentation will be the introduction to the radioactivity and its health risk, then assessment of radon and thoron in air, assessment of radon in water, assessment of uranium in water, assessment of radionuclides in soil, assessments of heavy metals in soil and water. And I would request you people that not to restrict yourself to the listener mode only. You can always ask, or you could always discuss the things if you are interested that why it is so, even during the talk. And during the tenure of this course, we will be planning in such a fashion that at the 5th day we are having a small quiz type of test for you people also, that how you have understood the radioactivity, and based upon your understanding you could answer that very minor quiz, which is a very normal type of a quiz, which is equally important for a layman, so who is not working in the nuclear physics only, but he is a person who is dealing with some of the radioactive materials. Like you go for medical diagnostics, you have undergone an x-ray. Have you ever asked that how much radiation exposure has been given to me? Nobody asks. In India especially, nobody asks. If you go for a CT scan, if you go for a PET scan, no doctor, no radiologist give you an idea that you have been exposed to this much of radiations. So these are the artificial radiations or the medical radiations, apart from the natural radiations which you are under the influence. So the combined effect of internal, natural, as well as anthropogenic, or you could say artificial, gives you a total dose. So that is why understanding of natural sources is very important, because natural is which we cannot avoid. So like if you are sitting in the room has a different type of environmental factors. One is the air inside the room, second is the ventilation conditions, third is the your relative humidity. So all of these parameters play an important role. And apart from this, the type of choice of building materials in the room also plays a very important for your exposure. So it is very important to understand that how we are going to get the information about the natural sources as well as the anthropogenic sources, that is due to the human activities. So if you just divide the radiation, it is basically of 2 types. One is the natural sources, which we generally call the cosmic radiation, terrestrial radiations, internal sources, and another are the anthropogenic sources, that is due to the human activities. One may be the medical sources, then consumer products which you are using, they may also give you exposure to the natural radiations. Then there are some industrial sources which can also give you exposure. So it is very important to understand that how much we are under the influence of natural sources, how much we are under the influence of anthropogenic sources. Now, if you talk about the radioactivity, it is not a new thing. It was present since last so many years, like from the mother earth. The age of the earth is the same as the half-life of the uranium. So if we divide the radioactivity or radioactive material, we are generally dealing with alpha, beta and gamma rays. And this slides give you an idea that how alpha, beta, gamma, and fourth one we have kept as a neutron. Though neutrons are not directly radioactive in nature, but once the neutrons fall on some of the materials, they cause alpha, beta and gamma to come out. So that is why we have categorized it to 4 categories. And if you see this figure, the alphas could be stopped by a thin sheet of paper. Similarly, the beta could penetrate through the paper, but they can be stopped by thin metal sheets. And similarly, the gammas, they have more penetration power and they could be stopped by the thick lead or steel plates. And finally, the neutrons, they are highly penetrating and we generally use the paraffin wax or water or concrete to stop the neutrons. Now, if you see from this figure, one could have an idea that if we are wearing some clothes, so we are not exposed to the alpha radiations. Okay, it's good enough. By seeing this figure, you could see that it could be stopped by a thin sheet of paper. So my clothes could stop the alpha sources. So it is very much right. But suppose you inhale an alpha source with your breath. So once you breathe, if you inhale an alpha source, it can enter your lungs. So if it cannot go inside from outside environment, so it cannot come outside from inside environment also. So means if you have inhaled an alpha sources during breathing process, so that alpha will enter into your lungs and will release its energy within the internal lining of your lungs, like on the thin sheet of paper. Now if you see all these 4 alpha, beta and gamma and neutron, and suppose you are having the same energy for all the parameters, like alpha is say for example 2 MeV, beta is also 2 MeV, gamma is also 2 MeV and neutron is also 2 MeV. Now from this figure you could imagine that the 2 MeV of energy will be released on the thin sheet of paper in the first case, and in the second case out of the 2 MeV some of the energy will be released on thin sheet of paper and rest will penetrate and then it will be stopped by the thin metal sheet in the second case. Now in the third case, if you see this cursor, you could see in the third case same 2 MeV energy is released on, a part is released on the thin sheet of paper, a part is released on the thin metal sheet, and then final remaining energy is released on the thick lead or steel plates. Now by seeing this, you could imagine that for same type of energy, the damage caused by alpha is the highest. Because for same energy of say for example 2 MeV which we were discussing, the maximum release of 2 MeV is in the case of alpha. So the reason is the alpha has the highest ionization power. So that is why alpha sources are very important to study. The reason being they have the highest ionization power and they can release their energy within a particular area on which they strike. So if you have inhaled an alpha sources like radon, which Dr. Tokonami was telling you about radon and its isotope, and the thoron also in the morning, they all are the alpha sources, alpha emitters. So if you inhale those sources which are present in the natural environment, so that release of alpha within the internal lining of your lungs, because you have inhaled it, could damage the internal lining of your lungs. So that is why the study of alpha sources is very important, as they have a high ionization effect as compared to the beta and gamma. And second thing is, the naturally available source of radiation, that is radon, is a alpha source. So now sometimes this is a very basic figure which we generally, it is prepared by one of my students, Dr. Sarabjot. So we generally prefer these type of figures to make you people understand that though you are not a man from a particular radiation field, you could understand why we use the different sources. Sometimes we say it is Becquerel, sometimes we say it is Gray, sometimes we say it is civet. So you could imagine from this figure that if you are only measuring the natural radioactivity, that is the disintegrations per second, so it is measured in terms of becquerels. So becquerels in the sense, that is the number of disintegrations per second. Suppose the natural radioactivity present in a particular area or a room. So it is measured in terms of becquerels, that is the number of disintegrations per second. Now suppose a passenger has a nap beneath that tree on which the apples were falling. So from seeing this, you could imagine that the green apples shown in the figure are the apples who are having impact on that passenger, who is having a nap beneath that tree. So that means he is absorbing out of the disintegration only the green color apples. So these absorbed doses are measured in terms of gray. And then the impact of these absorbed doses is the hump which is created. Though hump will not be created with the apples, but just for your imagination, a hump, that is the effect which is being created by the absorbed dose, is called effective dose, and that is measured in terms of civets. So this is the idea behind this, that why we use different sources, Becquerel, Gray or civets, for different types of exposures. So if it is a disintegrations per second, maybe a room might be having a very high level of disintegration per second, but if I don't enter into that room, I will not absorb anything. So once I say I have absorbed it, it is a gray in terms of measured in terms of gray, that is my absorbed doses. And once I say it is the impact of my absorbed doses, that is in terms of civets, that is effective doses. Now comes why we study the radiations. Means what is the reason why we study those radiations? Now in the morning, Dr. Tokonami has discussed a lot of things about the radon, why we study radon, because it is an alpha emitter. So here it is the same type of a figure which I am showing you, that out of this total contribution, including the man-made and the natural and the medical or the nuclear, everything, 55% contribution is only due to the radon. So nearly 82% contribution is from the natural sources and around 18% concentration is from the man-made sources. So which includes the medical, X-ray, nuclear medicines, consumer products. And out of this total 100%, nearly 55% contribution is only due to one source, that is radon. So that is why the study of radon is very important. So these radiations, though they are invisible, but they are very important, they are very dangerous if they have been exposed or if they have been absorbed at a rate more than the recommended action levels. So the average action level recommended for different radiations is different, and if you have exposure more than those recommended action levels, so it is always considered as dangerous. Now if you see from the figure on the right hand side, that what is the effect? Because if you see, exposure is in terms of millisievert, because it is the effective dose which we are calculating, that is in terms of sieverts, that is how much the damage has been caused by the absorbed doses. So which we are measuring in terms of sieverts. Sievert is a very bigger unit, so we generally use a small unit, that is a millisievert or microsieverts. So if you see from the figure, an exposure of around 50 to 100 millisievert can change the blood chemistry, and exposure of around 500 millisieverts can cause you the nausea. And impact could be measured within hours. So if you have been exposed to this much of radiation, say 500 millisieverts, within hours you will have a nausea type of a feeling. And if you have more exposure, you could feel the vomiting, hair losses, diarrhea, hemorrhage. And then if the exposure is around 1000 sievert, so impact could be the death of the person also. But these are very bigger units. Naturally, you are not exposed to these much of radiations. You are very limited to very small value of natural exposure, which we will discuss. So around 2.5 millisievert you are being exposed, and out of this nearly 1.5 is the contribution from the radon itself. So that is 55% contribution of the natural. Now, there are some important techniques to measure the radionuclides and heavy metals. And here I am presenting the basic idea of those techniques. That details we will be discussing in our next lecture. This is just a beginning of the course where we could give you an idea that what we are interested in. So we are interested in measuring the radon and thoron in air. Thoron, why it is important, Dr. Tokonami in the morning has explained in detail that the thorium series is also very important, and thoron is a decay product of thoron, and it is very volatile also. So that is why its study is very important, because it can have a different type of impact. And secondly, the alpha particles emitted by thoron, they are having quite big energy. So that is why their study is very important. And then we study the natural radioactivity in soil in terms of uranium, radium, thorium, and potassium. And for these measurements, we generally prefer different techniques which are mentioned here. One is the fission track registration technique. Another is the gamma ray spectroscopy. That is, we could use high purity germanium detectors also, and we could use sodium iodide detectors as a scintillation counter also for the measurement of uranium, radium, thorium, and potassium in soils. We can also study the uranium in waters, and this instrument which is shown here is a LED fluorimeter. But we could have very advanced techniques also apart from this LED fluorimeter, that is the ICP-MS, induced coupled plasma mass spectrometry, and where even with the help of a AAS, atomic absorption spectrometer, you could measure the uranium in water. And similarly, the other heavy metals you could measure in the different water or soil samples, which are these are the two detectors which are available in our lab. One is the atomic absorption spectrometer. This is on the left side, and this is ICP-MS, induced coupled plasma mass spectrometer. So where we could measure the heavy metals in soil as well as in water. Basically, both the instruments work on the liquid samples, but for soil samples, we have to use a microwave digester to digest those soil samples and finally make them in a liquid form, and then we could use those samples for the estimation of the heavy metals in those water samples. Now, this is a very important technique which is used for the measurement of radon and thoron and its progeny. Progeny, you could say, is a daughter product. So it is because radon is 55% contributor in the environment. So it is very important to study the radon as well as the thoron and their daughter products. So this is the technique which is being developed by the BRC, Baba Atomic Research Center, and it is very widely acceptable nowadays. Especially in the Indian environment, they have calibrated it in such a fashion that we are using two detectors within this pinhole cup dosimeters. And if you see from the figure, this pinhole cup dosimeter, there are two red color tapes which are there. So this is a detector which is a cellulose nitrate detector. Presently, its manufacturing has been ceased. We are working on some other detectors also, CR39 and another cellulose nitrate films, which are sensitive for the energy emitted by the alpha particle of radon and thoron. So generally, these detector has a sensitivity value of the order of 4.5 to 5 MeV, and the alpha particles emitted by the radon as well as the thoron, and if you allow the distance of around say 4 or 5 centimeter to travel, and if that alpha particle of around 8 MeV or 7 MeV travels a distance of 4 or 5 centimeter as per the Bragg's curve, it comes into the energy range of the sensitivity of this detector. And once it strikes this detector, it gives a track, that is an damage which is being caused by that alpha particle on this material. So this damage is called the track, and there is a very famous book, especially for the beginners. I would recommend that they should understand the basic physics of track formulation, and Walker, Fletcher and Price book is there, which gives you a very basic idea that how the energy, once it strikes the material, how a track or a damage is caused, and how to measure those damages. Now we are having some advanced techniques. We are having some spark counters which can measure those damages within minutes. But previously, when we were pursuing our research 10 years or 15 years back, so we were counting those tracks or damages with the help of our optical microscopes. So around 400 magnification microscopes which we were using, and then we were counting the damages. And then by applying some of the formulas or comparative techniques, we could understand that this damage is causing this much of damage is there within say a particular period of 3 months or 4 months. Now after this much of tracks have been reported, then we convert those tracks into the concentration. And now with the advanced techniques, it is very easy to measure the damages with the tracks with the help of a spark counters. So BRC has given a formula which you could note down, or which of course we will be sharing these course material to you also. You need not to note it down right now. So depending upon the radon, upper formula means depending upon the track and the background. Days means the number of days for which this detector has been hanged. Generally, it is recommended to hang it for at least 3 months. Then again, the tracks per centimeter square per day. So roughly, if you say by using the effective equivalent concentration or the values of the tracks which we have measured after suspension of these detector for say 3 months, for 4 months, depending upon the seasonal requirements. Like in India, we generally have 4 types of seasons. We prefer to suspend these detectors within seasons of spring, winter, summer, and autumn, 3 months each for 90 days. We suspend these detectors, and this upper compartment and the lower compartment of the pinhole cup dosimeter, the lower one is called the radon plus thoron compartment, and the upper one is called the radon compartment. The reason is through these pinholes, the gas will enter from the bottom and this is actually where it has been suspended. At least some protocols have to be followed while suspension of these dosimeters. The reason is it should not be affected by the direct building materials, because if you suspend it very close to the walls, the plaster of the walls which is having a cement concentration, that may give you an idea, that may give you an effect, that how this cement or the natural material, natural building material which you have used, or even the tiles or different materials on the walls, they could also affect. So we just want to hang it in such a fashion that it is not affected by the outside environment in terms of building materials, because we want to measure only the natural that is within the air. So that is why they are suspended at least 1 to 2 feet below the ceiling and 1 to 2 feet away from the walls, so that the impact of direct building materials is not there. So only the air surrounding the detectors within the range of 3 or 4 centimeters could affect it, and finally it will give you an idea. So as the thoron is highly volatile, there are 4 holes which have been provided in this pinhole cup dosimeter. So out of these 4 holes at 90 degree to each other, if you could see from this cursor, at 90 degree to each other, there are 4 holes which have been provided, and these 4 holes allow the radon to enter into the second compartment, that is upper compartment, from the lower compartment. So in the first compartment, there is a radon plus thoron, and this thoron is restricted only to the first compartment, and only radon is allowed to pass through the 4 holes. Then these 4 holes allow the radon to enter into this compartment and finally affect the LR115 placed on the upper body. So this total pinhole cup dosimeter gives you an idea that the lower compartment is the radon plus thoron compartment, and the upper compartment is the radon compartment. So if you measure the damage across the lower compartment or the lower detector, it is the damage which has been caused by the radon as well as the thoron, and in the upper compartment the damage is caused only by the radon. So you could see from this figure that this lower detector which is there, it is affected by radon as well as thoron, and the upper detector is affected only by the radon. And if you remove these detector after say 3 months and then do some chemical etching, which we generally follow in the sodium hydroxide, we will discuss those things in detail when we will discuss that how to exactly measure the value concentrations. So with the help of sodium hydroxide, these damages are being made permanent, and then finally the detectors are ready for the counting. And we use these formulas by measuring the number of tracks per centimeter square per day. We could estimate the effective equivalent concentration in terms of becquerel per meter cube. So in the first compartment, that is in the lower compartment, there is a radon plus thoron concentration, and in the upper compartment there is only the radon concentration. So if you reduce the radon concentration from the radon plus thoron concentrations, you are left with the thoron concentration. So that is why these 2 detectors have been provided. One gave you idea of radon plus thoron, another gave you idea of radon, and the difference of those 2 is the concentration or the contribution of thoron, because there is no other way directly to measure the thoron concentration with a very simple technique. Of course there are some instruments, but this is a very simple technique. Detectors cost you around 1000 rupees. You can hang this detector, and this film also cost you very less, and then after 3 months you could have an exposure in the indoor environment. That what is the general rough idea of exposure of radon and thoron in our environment. And generally it is recommended that your internal houses action level for radon, and radon is around 100 to 300 becquerel per meter cube. 100 is for new buildings and 300 is for old buildings. Sometimes it is being asked by the researchers or the students, sir, why there is a difference of 100 for the new buildings and 300 for the old buildings? Because even 300 becquerel per meter cube is not, it is a recommended action level, mind it is not the safe limit. So means if you are having exposure even 300 becquerel per meter cube, it doesn't mean that you have been exposed to very high level of radiations. It only means your exposure of natural radiation is little bit higher as compared to the other persons who are having lesser than 300. So it is recommended action level while designing or while manufacturing the houses or the dwellings. It is suggested that your choice of building material should be such that your exposure doesn't crosses the 100 for the new buildings. But in the old buildings, as we cannot immediately change all the type of building materials, we can only have a choice of little bit ventilation conditions. So exposure is at a little bit higher side. So it is best to have a maximum ventilation in the environment, and that type of choice of building materials which give you a lesser exposure as compared to the other building materials like granite. If you use granite, it is naturally radioactive in nature, so it will give you more exposure. But if you use, instead of granite, if you use a sandstone, it will give you a lesser exposure. So choice of building material is also very important. So it is not only the field of a physicist or a environmental scientist, but architects, civil engineers, they should also sit together while designing the buildings, while designing the apartments, what type of building materials they should use. That also plays a very important role. So these are the another detectors which have been developed by the BRC people, Baba Atomic Research Center people, which we call as a DTPS and DRPS. And if you see from the previous finger, this is the DTPS and DRPS which are hanged together with the spin hole cup dosimeters. So if you see from this figure, this LR115 is having a filtered layer, filter paper is placed of a luminized mylar. On the one side it is around 50 micrometer, on the other side it is around 37 micrometer. The reason for this is, as I have already told you, that our film is sensitive for energy range of around 4.5 to 5 MeV. And from the DRPS, direct radon progeny sensor, there is a isotope of radon which we call as plutonium 214, which emits an alpha particle of the energy of the order of 7.69 MeV. Now this 7.69 MeV energy is higher as compared to the sensitivity of this detector. So to make this energy come into the sensitivity range, we have to use a filter. So this filter is approximately of 37 micrometers. And if you are measuring the thoron, that is 220, then one alpha is emitted, it comes out to be 216, and if another alpha is emitted, it comes out to be 212 polonium. So this 212 polonium emits an alpha particle of the energy ranging from 8.78 MeV. So it is little bit on a higher side as compared to the polonium 214. So we have to use a bigger absorber, so as a filter, so that excess amount of energy is being absorbed by this aluminized mylar, and finally only 4.5 to 5 MeV of energy is released across this aluminized mylar and falls on this LR115, so that it comes into the sensitivity range of our detector. So rest of the things are the geometry or the locks which have been provided. So this is a detector and this is an absorber. So on the one side, for detection of radon progeny, that is daughter product, that is polonium-214, we are using an absorber of around 37 micrometer. On the other side, for the direct thoron progeny sensor, where we are directly measuring the daughter products of thoron, that is polonium-212. So we are using an absorber of around 50 micrometer because polonium-212 gives alpha particle of the energy ranging to 8.78 MeV. So of course, these are the minimum detection limits. For DTPS, it is 1 becquerel per meter cube. DRPS, it is 1 becquerel per meter cube, and for DTPS, it is 0.1 becquerel per meter cube. So this is the sensitivity range. Of course, we can also filter out the aerosols combinations by placing a wire mesh over this detector. So from which we could separate some minute and finer particles also. So that type of detection could also be done. So these are the few protocols for the measurement. Especially the important protocol is the choice of the seasons for which you are going to measure. Like I said, in India, generally we prefer 90 days in India, minimum 90 days, so that we could cover all the 4 seasons. But you could have a choice of 4 months also. That means you could divide the year into 4 months range. It's not starting from January only. You could have it from November, December, January, February, and then from March, April, May, June, and then July, August, September, October. So you could divide it as per the convenience of your cycles or even your seasons. Because even in India, if you say, the regional diversity is there and seasons are different in different areas. So the choice of the measurement should be taken in such a fashion that you providently cover all the different seasons available. And then after 4 months or after 3 months, if you are using a 4 months, means 3 seasons channel, or if you are using a 3 months as a 4 season channel, you have to remove those detectors and finally do the chemical etching process, which I have already told you, that is around sodium hydroxide of 2.5 normal is used, and at around 60 degrees Celsius for 90 minutes we go for etching so that the tracks become fixed. Then our tracks are visible and you could count those with the help of spark counters, or previously we were using some of the optical microscopes or electronic microscopes you could use. And then again the background track density, you have to take the measurements and finally remove those background parameters. And then based upon the concentration, you could calculate the final annual effective dose. And if you see the CRN, that is the concentration of radon, will give you the final annual effective dose. That depends upon the total year span and dose conversion factors. And finally, you could estimate the details. Now, similarly, with the help of a detector which is very important, that is RAD7, you could measure the radon concentration in water. And its operating principle is very simple. You just bubble out the radon gas present in the water with the help of the bubbling pump, and then from the bubbles, once the gas comes out, we go for the measurement. And this is a simple diagram. Of course, we will discuss those things in detail once we will be discussing the detailed parameters. Then we are also interested in measurement of uranium in water. And for estimation of uranium in water, previously we were using the fission track registration techniques. Then we come to the laser fluorimetry. Now we are using LED fluorimeter and ICP-MS, which are the advanced techniques. So out of this uranium concentration in water, the important parameter generally we measure is the uranium 238, uh, because it is present in abundance. And if you see the concentration, more than 99% contribution is uranium 238 is present. And why it is important? Because uranium, suppose you are having a concentration of uranium in water, once you have collected some water samples, it is not possible, or you can't say that the source is the same from where you have collected. The reason is the hexavalent component of uranium, that is U6 plus, that is water soluble. So if the thing is water soluble, so once uranium is present, suppose a river is flowing and it comes into in alignment with the uranium concentration in some groundwaters, and the source is 100 kilometers away, but it is having hexavalent component, so that will be soluble in water and that will continue to flow across the river. So by taking the water samples from a particular place, especially in terms of rivers or channels or canals, you can't say that the source is the same. If you extract the groundwater from the soil with the help of hand pumps or some motors or other, of course, the source will be from that particular depth. But in terms of rivers or in terms of channels, the source may be 100 kilometers away. So that is why it is very important to have an idea that what type of measurements you are performing and how you are collecting the samples. Similarly, this is the process working principle of LED fluorimeter, which has been given to you. Like of course, we will plan some workshop also during this final day. We will show you some of the live demonstrations of processes where you could have an idea that how we are going to measure it. So we will be performing some experiments, and I would request Abhishek and his team to get ready for the experimentation process in the last day, where we were having some hands-on training to them, so that they could have a direct idea that how we are going to measure. Similarly, after measurement of radon concentration, uranium concentration, heavy metal concentration, we could measure the radium, thorium, and potassium in soil samples. And this is how we generally collect the soil, finally filter out those soils, crush those soils in a fine powder and dry them. And then, of course, to remove the water level, or we just dry those soil samples for 3 hours at around 100 degrees Celsius. Then the samples are being sieved, they are being measured, and finally they are packed at least for 3 months. The reason is the humidity has to be removed from the soil samples, and the packing is to be done in such a fashion that each container should match up with the geometry of the required geometry of your measuring instrument. So if you change the geometry of the measuring instrument or the geometry of this container, the results would vary. So that is why it is very important to use a right shape and size of the packing material in which you are packing the samples for at least 6 to 8 months before measurement, so that the naturally radioactive equilibrium could be attained before measurements. And then you could place those samples within the compartment available for this measurement process. And like this is the instrument which is available in our lab, that is a scintillation counter. So where you could place your sample and finally go for the gamma ray spectroscopy techniques for the estimation of different radium, thorium, and potassium concentration in soil samples. So similarly, for the assessment of heavy metal in soil and water, we could prepare those samples. Like in case of soils, I have told you that our instruments, either ICP-MS or AAS, they work on the liquid samples. So for in case of soil samples, we have to use a microwave digester, and with the help of those digester, we could convert our soil samples into the liquid samples, and finally we could use those techniques which we will discuss uh, in detail in our next lectures, and we could measure. So these are the few important reports which have been published by our lab and our department, where the Tribune, the Hindustan Times, and even Doordarshan, PTC channels, so many channels have published our reports, because we generally go on pinching the government also, like if there is a high concentration in some areas, so we have to bell the cat. So we go on giving our reports in the different newspapers, print media also, so that we also remain in public, and public should know that what type of work we are doing and how it is impacting their health. And recently, from our report, the Punjab State Human Rights Commission has taken a cognizance of our report, and they have asked the Punjab Pollution Control Board to check the high concentration of chromium levels in Jalandhar. So that is why these type of studies are very important. So these are the facilities or the pictures of our lab. So I invite all of you to visit our lab anytime you want. We are ready for making collaborations with the different institute also. Like presently, I am working as a dean research and consultancy. Also in India, we are having so many collaborations with different IITs, different NITs, and even the state government organizations, where we do the joint publications, joint research, and submit even some joint projects, and even some proposals for the workshops and the seminars. So we are welcome, we are open to everyone. You could always contact us. So these are my numbers and emails. So for any case you require, you could always contact me. And before starting the next lecture, we could take a break for 10 minutes, and then we will be starting at 2:35 for the next lecture. So any question or any query if you are having, I'm ready to answer it. So Abhishek, you could note down some of the queries which are there in that component. And like some people are writing some chat box also.
Okay, sir.
Okay. So
Thank you very much, sir, for such an informative talk. Dear participants, we will start the next session, lecture of the session within 5 minutes.
So I will be joining maximum by 2:35. Okay.
Okay, sir. Thank you very much, sir.
Thank you. Thank you. We could have 10 minutes break, and then I will be joining. Thank you.